So hello guys, today we are going to do a leetcode question that goes by the name number of substrings containing all three characters. The question number is 1358 and it's a medium level question. So as you know the pattern, we will first try to read the problem statement and then we'll go on to the solution eventually. And sorry for the delay, like I have been busy in some kind of stuff to do, and that is why I was not able to post videos. Well, now I'll try to be regular. So let us try to get to the solution. Okay, and if you are not subscribed to the channel still now, just choose like, share, subscribe. Like only if you like the solution. Okay, I'm not forcing you to like, just do it only when you like the solution. I hope you will like it. Okay, so let us first try to read the problem statement and then we'll go on to the solution. So what is the problem statement? Given a string S consisting only of characters A, B and C, return the number of substrings containing at least one occurrence of all these characters A, B and C. Okay, so what I am given is, I am basically given a string and that string contains only characters A, B and C. Okay, return the number of substrings containing at least one occurrence of all these characters A, B and C. So I have to return a substring. I have to return a substring, number of substrings that contain all of these letters at least once. Okay, so you just tell me what is the minimum string that can be formed from using all these letters. Yes, you are right. A, B and C is the minimum string or substring that can be formed by if it is compulsory to take all the three letters, minimum string that can be formed by compulsorily taking all the three letters, okay, compulsorily taking all the three letters. Okay, so I have to find the number of substrings, but it is given that at least once. So this could also be my answer, as it contains A equal to 2 times, B equal to 1 times and C equal to 1 time. Yes, A, B, B, C, C is also my answer, as it contains A equal to 2 times, B equal to 2 times, C equal to 2 times. Okay, A, B, C, and infinite times. I don't know how many times, maybe 10 raised to the power 5 times. Let us see the constraints. 5 into 10 raised to the power 4, so minus 2, that number of times. So yes, it is also a valid substring, so I'll count it in my answer. My count would still increase. Now I'll consider what are not my answers. Okay, what are not my answers? Suppose you are given a substring like this, AB. You are given with A, you are given with B, but are you given with C? No. So this is not simply my answer, because I am given that I have to have at least one occurrence of all of these characters. Okay, so in this case, C remains empty. Okay, is this my answer? In this, A occurrence is 1, B occurrence is 0 and C occurrence is 0. Is this my answer? No, because B should have an occurrence of at least 1 and these both are not satisfying the condition. So this is also not my answer. Is this my answer? A, B. Is this my answer? A is 4 times, B is 4 times. Is this my answer? No, still no. Why? Because C is equal to 0. If my C is equal to 0, that is not simply following my condition. So that is not my answer. Okay, that is not my answer. So what is my answer? Okay, so only the valid substrings are that contains A, B, C at least once. Just remember this. Any other occurrences like A, B greater than or equal to 1 are allowed. Okay, but less than 1 are not allowed. 1 should be the minimum number. That is what we meant by the question. Okay, if we just try to see this test case, ABC, A, B, C, A, B, C. Okay. What are the substrings that contain the letter A, B, and C at least once? Okay. We'll also try to see the brute force solution this approach. What can be the brute force solution? Okay. What can be my brute force solution is to get all the substrings, using my regular substrings, using my regular n square method, that is to generate all the substrings and check whether all the three characters have a frequency of greater than equal to 1, like A should be greater than equal to 1, B should be greater than equal to 1, and C should be equal to greater than equal to 1. And when I am satisfying this condition, just increase my count. Suppose basically you are given like this, you can generate basically all the substrings. So what are the substrings starting at A? A, AB, ABC, ABCA, ABCAB, ABCABC, okay, B, BC, BCA, then BCAB, BCABC, okay, C, CA, starting at C, C, CA, then CAB, then CABC, okay, starting at A, AB, and then ABC, okay, starting at B, B, and then BC, and then at last C. So these are all the substrings that could be generated. Simply I just started at all the indexes and moved towards the end. So these are the number of substrings that are produced. Okay, now I'll check for the condition. Does this contain all the three occurrences of A, B, and C? No. I'll just discard this. Does this contain? No. Does this contain? Yes. So my counter is 1. Okay. Does this contain greater than equal to 1? Yes. A is occurring 2 times, B is occurring greater than equal to 1 time, and C is also occurring greater than equal to 1 time. So C would be 2. Okay. Is this following my condition? Yes. A, B, C are both all occurring, and they are all occurring greater than equal to 1. Okay. Is this my answer? Yes. Because yes, greater than equal to 1. Is this my answer? No. I'll just discard this. Is this my answer? No. Is this my answer? Yes. Because occurrence greater than equal to 1. Is this my answer? Yes, obviously, because occurrence greater than equal to 1. Is this my answer? Yes. Is this my answer? No. I'll just discard this. Is CA my answer? No. Is CAB my answer? Yes. Yes. So I'll simply increase my count. My count would be 8. Is CABC my answer? Yes. So I'll increase my count. Is A my answer? No. Is AB my answer? No. Is ABC my answer? Yes. I'll increase my count. My count becomes 10. Is B my answer? No. Is BC my answer? No. Is C my answer? No. Okay. So yes, we got a count of 10, and this is what is supposed to be 10. Okay. If you just try to notice a simple thing in this brute force solution, so this is the brute force solution. You just have to generate all the substrings, and whatever substrings are just following your conditions. Whenever the substrings are following your condition, you can just increase the count, and at last you will just return the count. I'll not give the brute force solution. I have given the brute force solution. Basically, I'll not give the code for this because it is very basic. I'll attach it in the description, but I'll not gonna explain it. Okay, it's just a simple O of n square approach of generating all the substrings and then checking for this condition. Okay, I'll just give the code in the description. So okay, now I'll come to what I'll come to. Yes, so if you just try to observe in this test case ABC, if you just try to observe, when I was starting from this index ABC, okay, when I was starting from A, I included A, then I included AB, then I included ABC. Okay, so this is the minimum string I'll get, minimum substring I'll get. Okay, and when this condition is being followed, now I know that all the other substrings starting including this, like this is my substring, that is the valid one, but is this also valid? Yes, yes, because see, ABC is already there. Okay, if you now include any number of elements, like A equal to 1, B equal to 1, and C equal to 1 is already being followed. Okay, now if it contains any number of elements, okay, so now if it contains 100 A's, 200 B's or 300 C's, is it gonna be falsing my condition? Like, will my condition ever be resulting to false? No, no, because I am given with a condition that my occurrences should be greater than equal to 1. Okay, and whenever this condition, basic condition, is met, that my substring is identified in which all the three characters have an occurrence of greater than equal to 1, basically equal to 1. Okay, so this is where I can simply identify that if this is my valid string, all the other strings would also be valid, like a b, like I'll just show you again. This was my answer. Like this is my string that is valid. Now abc is also my answer, abca is also my answer, abcab is also my answer, and abcabc is also my answer. So if this is my ending index at this position, basically 0 1 2 3 4 5, if this is my ending position and the string has a length of 6, so 6 minus 2 is equal to 4, I'll get 4 occurrences, I'll get 4 substrings, I'll get 4 substrings from this string. Basically, see, if you are given with this, okay, and here are some arbitrary values, okay, you know that this is your answer, this is your answer. And if you now can include any number of characters to your answer, this is one substring. If you include this is gonna be the second substring, yes. If you gonna include this also, this is gonna be a third substring, okay. If you're gonna include this is gonna be a fourth substring. If you're gonna include this also, then it is gonna be a fifth substring. If I just try to write out the indexes for 5, so 5 minus 0 is equal to 5 substrings, and that is what I am getting as my answer. That is what I am getting as my answer. So what I just observe it, what's the last index of my ending, like if like this contains a, b and c, the ending index of this condition, ending index, basically the size of array or vector minus the ending index of the substring, ending index of the substring that is following my condition, are the number of substrings that can be my answer, okay. Basically, if this is following my condition, this would also follow my condition, this would also follow my condition, this would also. I'll just show you one more test case. A is CB, okay, or I'll just make one ABC, AAABC, okay. If this is my case, if I just start from this index, from A, okay, now I know that ABC is included as my answer. So ABC is a part of my answer, ABC is part of my answer, okay. So ABC is part of my answer, okay. Now if I just include this, so if I just erase it, okay, this is, now I know that this is my answer, okay, this is my answer. So one substring is already produced, I have my substring as 1, count as 1, okay. If I include this, is it gonna result in a different substring? Because if this was ABC and A is included, so this is a different substring, but is this my answer? Yes, okay. Okay, so yeah, so this is a different substring and this is a different substring. So I know that if this is my answer, then this is also be a part of my answer, this is also a part of my answer, this is also a part of my answer, this is also a part of my answer, and I know that all of these are different substrings. Because I am given that the condition should be greater than, if my condition is already being followed, then this will also be following my condition. So A will also be following my condition, this. So what are the number of letters that will be increasing my substring by? 4, okay. So the total answer would be this plus the number of characters remaining. So this can be easily done by the formula n minus j, where j is the ending index of that particular condition. Okay, why I am telling you this? Because it, like this is a common approach and I don't want to just stick it to one question only, I don't want to stick it to one question. This is a common approach, this can be used in different questions also. So you just have to know this approach. Okay, you just have to know this approach. I have not come down to the optimal solution. This is just an approach that I have discussed. Yes, it can also be like performed in this, like n square solution. It can be also done. It's your choice. It's the optimization technique. Like it can reduce the number of operations by some steps. Like you don't have to just go through all the elements. Okay, so it reduces the number of operations. Okay, but remember that the condition should be greater than equal to something. Okay, so now coming back to the question, we discussed the brute force solution, but is the brute force solution enough? Because let us see the constraints. The constraints are 5 into 10 raised to power 4. So if I just try the n square solution, it would be resulting in 25 into 10 raised to power 8, and 10 raised to power 8 would give me TLE, because it would take approximately, basically greater than 1 second, and greater than 1 second operations are discarded. Okay, these are discarded, simply discarded. Okay, because online compiler can only execute between less than 1 second operations, less than equal to 1 second operations. So what is my optimal solution? Let us try to see. Before going on to the optimal solution, what is the thing that is taking our time? Is checking my condition taking my time? Basically, there are 2 steps only, right? 2 steps only in the brute force solution. First is to generate all the substrings. Okay. The second is to check the condition in each substring. Check the condition in each substring. So what do you think is the bottleneck for our solution? Is this the mandatory step that should be taken? Like, because you have to check the condition in order to specify if this is a valid substring or not. So this is to be done. This is a compulsory step. I cannot avoid this. But can I just optimize this generate all the substrings procedure? Maybe, because this is what is causing me of n square time basically. This is what is taking my n square time. So can I optimize this? Let us see. So you just figured out. I just told you an approach that if there is a window, if there is a substring that is following my condition, like this is a substring that is following my condition, then all the other letters, this would be included. So the number of substrings would be n minus j. But for this, I have to find this first. Basically first substring that is following my condition, and then I can dynamically reduce the size as well as increase the size of the window. So and in this general questions also, like where you are asked to generate the substrings, the most optimal way, in some cases, not all cases, okay, in not all cases this would work, but in most cases, what is the approach? 2-pointer sliding window approach. 2-pointer plus sliding window. This is used to generate all the substrings, and if I use this to generate the substrings of O of n time or O of 2n time, then this would be reducing my complexity. And if I am able to reduce my complexity by this, using this, then my code would run. Obviously. Okay. So let us try to see. Okay. Suppose you are given with this string ABC and ABC. Okay. What I need to figure out for my condition that all the characters should be present. At least once. That is, should be greater than equal to 1. So for mapping all the elements frequencies, what is the best data structure that comes to my mind? Yes, map is an easy one. I'll tell you why it is convenient to use a map in this case. For me, it was convenient. I don't know about other approaches. Okay, like I found this approach pretty convenient. Okay, because I don't have to traverse and just check. I'll tell you how. Okay. See, if you just traverse, if you just use the 2-pointer sliding window approach and you start from the first index, you'll just follow this condition till your condition is not satisfied. Till your condition is not satisfied. Increase the window size. Increase the window size, and if your condition is satisfied, then decrease the window size till it doesn't satisfy again. Decrease your window size till it doesn't satisfy again. Okay, what I mean by this is basically, see, you're given with this A, B, C, A, B, and C. Okay, I'll try to explain you the approach. This is my I pointer and this is my J pointer. Okay, what I'm doing is I'm using a map, and I know that the string can only contain A, B, and C. You could use this like counter 1, counter 2, and counter 3. I prefer using a map. I don't know. Okay, so okay, what I'll do is, if my condition is not being satisfied, I'll increase my J pointer, and if my condition is being satisfied, if my condition is satisfied, I'll increase the count of substrings. Suppose my count is initially 0. I'll increase my count of substring. Count is increased, and I pointer is incremented. To look for other substrings, other valid substrings. Incremented to look for other valid substrings. Let us try to see. Okay. Suppose we are given with A, B, C, and my pointers are right here. This is my I pointer, this is my J pointer. Okay. What I'll try to do is, here comes my first index. I'll map it to the map. Okay. So A comes one time. Okay. But is it following my condition? How should I check my condition? Basically, if my map size is equal to 3, then it is following my condition. Why I could say that? Because see, there can be max 3 elements, right? 3 characters only, right? A, B, and C. And if my map size and map contains only unique elements, okay. So if my map size is equal to 3, that means all the 3 elements are present in the map. So this can be my checking condition. Okay. So till my map size is less than 3, I'll increase my J pointer, and when my map size is greater than equal to 3, I'll increase my I pointer. Okay, and I'll increment my count. This is a general approach we use in 2-pointer sliding window questions. Okay, so I'll come to the first index. I find out, I'll just write it down here. A, B, C, A, B, and C. This is my map. I'll come to the first index. My I is here, my J is here. Okay. I'll come to the first index. I found out that it is A. Okay. I increase its occurrence. A becomes one time, but is it following my condition? Is my map size equal to 3? No. I'll come here. I'll come at this index. I'll increase the occurrence of B. Okay. B occurs one time. Okay. But is my map size equal to 3? No. Okay. I'll increase my J pointer. Okay. Here comes my C. Is my C equal to 1? Is my map size equal to 3? No. Is my map size equal to 3? No. Is it? No. Now the map size becomes equal to 3. So this is where my first condition is being met. This is where my conditions are being met. Now, this is my valid subarray. This is my valid substring. Okay. Now I know if this is my valid substring, all the other characters that are all the characters that are just in front of them will also form a valid substring, will also form a valid substring, So 0, 1, 2, if I just try to number them, by how much should my count should increase? Basically, see this last index, and how many characters contribute to the substring? 6 minus 2, simply 6 minus 2, that is the size minus the last index, 4. Because see, this is my first valid substring, and these all are also making 1, 1, 1 substring. So 1, 2, 3, 3 plus 1, 4. My count should be incremented by 4. I delete all this to make it easily understandable to you. Okay. Now, when my substring is equal to 3, what is the next step that I shall do? Okay. I'll increment my I pointer. Obviously, I'll increment my I pointer. Okay. So my I pointer will be incremented, but before incrementing, I'll just reduce the occurrence of this. Okay. So my A would be 0, so I'll remove that from the map, and my map size decreases. My I pointer comes here. Okay. When my I pointer comes here, I'll see that map size has again become less than 3. Okay. So this is where I'll still increase my J pointer. Okay, my J pointer is increased. J pointer has come here. Is this the occurrence of A? Yes. So A would be 1. Is my map size equal to 3? Yes. So this is the last occurrence, and my size is 6. So 6 minus 3 is equal to 3. So 3 elements should be added to the count. Counter becomes 7. Okay. And when my map size has become equal to 3, what I'll do is I'll simply increment my I pointer, and before incrementing, I'll just delete its occurrence from the map. Okay. I pointer comes here. Is the map size again less than 3? Yes. So what I shall do, I'll increment my J pointer. My J pointer comes here. B has an occurrence of 1. Okay. Is my map size equal to 3? Yes. So can it contribute to my answer? Yes, obviously. So 6 minus 4, that is equal to 2, and 2 should be incremented to my count. Count becomes 7 plus 2 is equal to 9. Okay. And when the map size has become equal to 3, what is my next step? I'll simply increment the value of I. But before incrementing, what I'll do, I'll simply delete this occurrence, and when deleting, my I pointers come here. When deleting, now my map size become less than 3. What I'll do, I'll increment my J pointer. My J pointer has been incremented. And my C has become equal to 1. Now my map size equal to 3. Map size has again become equal to 3. So again it would be added. So 6, that is the size, minus the last occurrence, that is 1. So 9 plus 1, that is 10. And in the next step, what would happen is I pointer would be incremented. Okay, and this occurrence of A would be deleted. And then when the map size would become less than 3, J pointer would be incremented, J pointer would come here. And this is my stopping condition. Okay, this is where the condition stops. What is the final value of my count? 10. Yes, and this is what is my answer. 10. See, here are we considering all the substrings? Yes. See, you have considered this substring, you have considered this, you have considered this, you have considered this. You have basically considered all the substring in this. Okay, and what is the time complexity of a solution? Time complexity, basically only 2 pointers you are just traversing to the array. So the J pointer takes O of n time, and the ith pointer also takes O of n time. So that becomes O of 2 into n. I have reduced the time complexity from O of n squared to O of 2 into n. Amazing, right? So I'll just come to the second test case. I'll just try to show you AAA CB. Okay, A, C, and then B. So this is my scenario. I am given with a map that will store all the occurrences. Just remember, when my map size is less than 3, I have to increment my J pointer, and when my map size is equal to 3, I have to increment my I pointer. But before incrementing, I have to do some things that I have to increment my count, and I have to delete the occurrence from the map. I have to delete the particular character's occurrence from the map. As same as the previous test case, I and j pointer, I would be starting from the first index. Okay, so is my map size less than 3? Yes. So I would just log the first element. A is occurring one time. Okay. J pointer increases. Again, A comes. Is my map size less than 3? Yes. The occurrence of A increases. Okay. J pointer comes here. Is A occurring less than 3 times? Yes. So should the occurrence be increased? Yes. Okay. J pointer increases. This is a C value. Okay. C would come here. Yes, map size is still less than 3. I could easily see that. Now my map size is 2. Map size is 2. Okay. Still J pointer needs to be increased. J pointer comes here. J pointer comes here. Here comes a B. So B would be 1 in this case. And when B came, my map size is gonna be 3. Map size is gonna be 3. This is where the condition is being followed, and when the condition is being followed, I'll simply first what I'll do, I'll simply increase my count. The count should be incremented by 5 minus 4 equal to 1. Okay, and I pointer should be increased. But before increasing the I counter, just remember that you have to delete the occurrence from the map also. So if you are increasing the I pointer, suppose I pointer comes here, the occurrence of A reduces by 1, so A becomes 2. Okay, is the map still valid? Yes. Still equal to 3? Yes. So again count would be incremented. So 1 plus 5 minus 4, that becomes 2. Okay. I'll still increase my I pointer. Okay. I pointer comes here. Is this still a valid one? Is this still a valid one? Yes. Map size is still equal to 3. So 5 minus 4 will still be added. So 2 plus 1 equal to 3. Okay. I still increase my I pointer. Is it still valid? Because if I just increase my I pointer, A would be discarded from here. Map size would reduce to 2. And when my map size reduces to 2, what I have to do is I'll have to increment the J pointer. And when I increment my J pointer comes to the nth index. And this is where I stop. This is where I stop. Okay. So is 3 my correct answer? Yes. 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 Okay. I'll try the third test case also for you. ABC is the test case. This is my map. This is my ith index. This is my jth index. I'll continue to increase my j till my map size is less than 3. So I'll just log A here. Okay. I come to this index. I'll log B also as 1. Okay. I come to this index. I'll log C also as 1. Is it following my condition now? Yes. So my counter would increase by size is 3. Last point is at 2. 3 minus 2 is equal to 1. So count would be increased by 1. And after this has been followed, I pointer would try to increase. I pointer would come here. But when I pointer comes here, then in the next step, J pointer would increase. J pointer would increase. And when the J pointer would increase, it would come to the nth index. And this is where I stop. This is where I stop. So this was the overall approach. Now I'll try to code it for you. Okay. I'll try to first mention the size of the array, size of the string basically. I'll start from using the 2 pointers. The j should be less than n and my I should also be less than n. I should also be less than n. Okay. What I need is, I need an unordered map because that makes my work easy. I can simply check now. Why I have to make 3 variables and make it more complicated. So this seems simple to me. So what I'll do is, I'll simply increase my occurrence of j. Okay. If my map size is less than 3, what I have to do? I have to increase my j pointer. Yes. Yes. But if it is greater than 3, what I have to do? Greater than equal to 3. Basically, for safe case, and my I is less than j, what I'll do is, oh, I forgot to maintain a count variable that is initialized to 0. Okay. What I simply do is, I'll first increase my count by what? N minus j, where n is my size, n is size and j is the ending index of the window. Ending index of the window. Okay. So this is what is done to increase the count. So I'll just, now what I'll do is, I'll simply remove the occurrence of the ith character from my map. So I'll just decrement the count, and if that count has become equal to 0, I'll simply remove it from the map, right? Because if I don't remove it from the map size would still remain same, and that makes my work difficult. Okay, I'll simply increase the counter. I'll simply increase the ith variable. I'll write a safe case. Basically, in this cases, I'll write a safe case that if it is no, there is no need. Okay, I'll simply increase my j pointer at last, and what I'll try to return at last is I'll simply return the counter variable at last. So this was the code. I'll try to run it. The code has run successfully. I'll try to submit. So yes, submitted successfully. I'll just try to give an overview of the code to you. So what I'm doing is basically I'm declaring the 2 pointers here. 2 pointers are declared. Okay. Ending condition is being satisfied. A map is made to track the elements, to track the frequencies of elements. Okay. When I come here, this is the case. This is the case when my condition is not being followed. When my condition is not being followed. So this is the case when my condition is not being followed. And when my condition follows, I want the counter to increase its size by what number? See, this is my answer. All the other characters occurring after it would also contribute to one substring. Okay, so one from this and one from each of the characters. Okay, so suppose one from this and x characters the answer should be x plus 1. This is explicitly specified by if this is the nth number, this is the last index. So this would give me the overall answer. N minus j would give me the overall answer, and this is why I am increasing by n minus j. And when my condition is being satisfied, I'll increase the I pointer to reduce the size of the window. Then if the occurrence of the particular character becomes equal to 0, I'll simply erase it from the map. I'll increment my I pointer, then I'll increment my j pointer, and at last I'll return the count. So this was the code. What is the time and space complexity? Time complexity is basically O of 2 into n. Why? I already specified. See, one loop is for the jth variable and one loop is for the ith variable. So O into 2n. Am I using an extra space? What is the space complexity? Am I using an extra space? Unordered map. So shall it take O of n? No, because I know that at the max there can be 3 variables only. So O of 3, and that becomes O of 1. And simplifying it also, it becomes O of n. So this is the O of n time. I have reduced the time complexity from O of n square to O of n, and space complexity to O of 1. Okay. So this was the overall solution to the question. Number of substrings containing all the 3 characters. I hope you guys like the solution. If you have any doubts regarding the solution, you just ping it down in the comments. And if you like the solution, do like, share, subscribe. Thank you. Have a nice day. Bye bye.